This call is now being recorded.
Good morning. One and all present here for the today's session. ACT ATAL FDP 3D printing and design conduct third day 7th session. I warm welcome Dr. Rajesh Ranganathan, Professor Mechanical Engineering, Coimbatore Institute of Technology, Coimbatore. Today handle the session 7 for customization through additive manufacturing. So for the purpose, I invite Mr. K. Velusamy, Associate Professor, Department of Mechanical Engineering, KSRIT, Tiruchikonamakal District, Tamil Nadu. Introduce Velusamy, sir.
Good morning to one and all present here. I am very happy to introduce Dr. Rajesh Ranganathan, sir. He is currently working as a professor in Coimbatore Institute of Technology, Coimbatore, India. Working at CIT, he lectures modules in supply chain management and rapid manufacturing, additive manufacturing. He heads the Advanced Integrated Manufacturing and Management Research Group, AIMMRG at CIT, and Director for Center of Excellence in Manufacturing Sciences. Only center in India founded by Ministry of Human Resource and Development, Government of India. Dr. Rajesh is undergoing research work and consultancy in terms of integrating manufacturing, engineering, and healthcare technology. As an outcome of integration and upon establishing a research center, he holds project accounting a close to 4 crores. Dr. Rajesh, for his outstanding work on diabetic food management, received on Young Scientist Award from Department of Science and Technology, Government of India. He holds patents, 42 journals publications, 1 book with Amazon US holding its copyright. He has guided 10 PhDs and guiding 6 PhD scholars along with 2 research associates working in various research projects. He has well guided international PhD scholars. The outcome of undergone research were couple of new products in healthcare finding its novel applications to its end user, providing benefit to society. Patents were filed for the development of products undergoing in healthcare engineering involved in developing products for healthcare industry like diabetic food care products, surgical aids for pinhole surgery, customization of patents. Dr. Rajesh Ranganathan works closest with the diabetologists, orthopedicians, surgeons, dentists, and food product developing research institute, along with core research in new product development for healthcare, and started with consultancy based work with local hospitals and with some of the national and world class manufacturing industries, concentrating the product development adopting AM technologies. Working in the area of supply chain, Dr. Rajesh holds work experience as a knowledge transfer partnership associate working for oil and gas industries in Aberdeen, Scotland, UK, working as a consultant. Dr. Rajesh was also associated with the University of Aberdeen, UK as a knowledge transfer partnership associate, where he was building a gap between industry and academics. Prior to his career in oil and gas, Dr. Rajesh worked with the National Health Service UK and with leading healthcare industry in Europe in the areas of strategic planning, technological forecasting, inventory reduction, product customization, and manufacturing lead time production. Dr. Rajesh obtains his doctoral degree in additive manufacturing from Loughborough University, England, UK. During his PhD, he was the world's leading research group, Rapid Manufacturing Research Group. I welcome you, sir.
Thank you, sir.
Thank you. Thank you, sir.
Thanks for your kind
Thank you.
introduction, sir.
I welcome Dr. Rajesh Ranganathan, sir. The session is hand over here.
Thank you,
Okay, sir.
sir.
Thank you.
First of all, I'd like to thank Professor Mani for giving me this opportunity, and it's a quite a hot topic which he have chosen for this program. I thank you for giving me this opportunity, and all the very best for this event, sir. And very good morning to one and all who are here for this event. Like today, my topic of presentation is customization through additive manufacturing. In this, I would like to present some of the live case studies that we did as a research back at CAT. And I thought that would give you a clear idea of where additive manufacturing is moving in this particular domain. Like to start with, it's because like when it comes to additive manufacturing, I've been in this particular field since 2002. It was the time when I did my PhD. I did with one of the world's leading group in Loughborough, wherein I worked with Phil Dickens, Terry Wallace, Richard Egg during my PhD. And from that time onwards, we were looking into this particular field. And I can probably say that mine was the first thesis which looked in integrating additive manufacturing and supply chain and see where the potential of this particular technology would go ahead with in the year 2002. This was the time where we started focusing on. And some of our projections that we technologically forecasted through our research was coming up true. And so for that reason, I thought I'll give you a bit of outline why this is required and what made additive manufacturing to move faster, because this technology is roughly about 30 years old. Whereas if we take other subtractive manufacturing technologies, those were more than 200, 250 years old technology. And the movement of this additive manufacturing in past 30 years is quite wider as compared to the 250-year-old technology. And what is the real thing which is pushing it in? So that becomes a question. So I thought I'll shed some light on those areas. So it can be a hypothetical one saying customization is already happening, but it is happening around us. And of late, customers started demanding products specifically for their needs. We can take through a couple of examples on that, and then we'll get into additive manufacturing. So earlier, if you look into the marketplace, because marketplace is divided into two categories, one is the buyers and the sellers. Earlier, it was the seller's market, wherein the manufacturer produces a product and he pushes the product into the market, and then the customer tends to pick in. So those were the days where we could see these products which came in, and when these products were there, you don't find much of a change in product. One product comes in, it stays there for more than 15 years because it was seller's market. Whenever the seller decides to push another new product, that's how the product tends to change. Whereas in the current scenario, it's entirely changing. It is more or less like the market have taken a major shift from seller's market to buyer's market, because earlier the information flow line was very less, whereas now the information flow line is going very close to the manufacturing, and that is where the entire product have been changed. So that is why the change in control have came up from sellers to buyers market. Having said that, so what made this? So we'll go back to a bit of manufacturing, and then we'll come to additive manufacturing. So it was early days. It was more of a customization. We very well know that there were very highly skilled labor force wherein they were producing high custom products, and that will be one of its kind. If this person makes one product for a particular house, he wouldn't make a similar one for another house. He would have his own design. But we were not convinced when the demand came up, and that is where mass production came into existence with Henry Ford. And when he brought in, that's the time when standardization came into existence, and everything was produced, and all the cars that were produced was black in color. So it was mass production. And during the time itself, customers were, they took it, but after a point of time, they were not happy. Within mass production, they started to look in for customization. So that is why everything was standardized. But when it came to product final end products, they started changing the colors. So mass customization was taking place slightly. And with the internet era, it started changing drastically. And with the internet integration with the manufacturing, it started changing drastically, and modular customization came into existence. We'll see one or two examples for modular customization, and then we'll go back onto it. And the future, that is where we are looking at, is Industry 4.0, wherein already the highly skilled labor is missing. So we are trying to replace the highly skilled labor with newer technologies. And one of the technology is additive manufacturing, wherein they are trying to incorporate, or they're trying to overcome this high-end customer or the high-end manufacturer who was very skilled earlier. Now he's been trying to be replaced with additive manufacturing machine. So that's the flow we can see. And this is very clear that earlier it was seller's market. When mass production was there, it was seller's market. And when internet era, it is more of a buyer's market. And the buyer's market have already started, and we don't have labor force, or we can't employ people to make one of a product or one of high custom products. So that is why additive manufacturing comes in, and that's where the future looks like. So speaking of mass production to mass customization, even this little customer, she, given a choice, she would like to go for a product of her own choice. Like she would pick either of the colors. Some of it she might not be interested, and she would pick up one color. That is nothing but from mass production, we have moved to mass customization, wherein even a tiny customer demands a product of her choice. Given this option to an elderly customer, or better, older customer to a middle-aged customer, let's say that she wants to pick a laptop of her choice, and you have five criteria what people generally take in for purchasing a product. And looking at, though they have all the five criteria, when they go to the marketplace, still they would miss up something, and they would make a compromise in getting a product. Let's say for this particular customer, she wanted to have, she has a particular spec, and she goes for shopping, and there she realizes that all she can do is, for her spec, she need to get a 17-inch bulky laptop. But her requirement was 11-inch laptop, but she can't go for it because for her spec, what she was looking at, she need to go for a bulkier one. So this made some of the manufacturers to think about, and that is where, in the internet age, manufacturers started off going for mass customization. Let us take Dell as an example. In Dell, as a customer, you can log in, and once you're logged in, you can pick and choose the product configuration that you want. And after configuring the product of your requirement, the product will be delivered to you, and here the customer doesn't need to make a compromise. If she wants 11-inch screen with a particular spec, yes, she will definitely get that 11-inch screen with that particular spec. And all this product that was made is specifically made for this particular customer. It's not like mass produced and she picks one from that mass produced one. Going through this example quickly, like she has an option to pick the screens, She has the option to pick and choose the processor, memory, hard disk size, processor, operating system, and from operating system she can even decide in what lead time she wants the product to be delivered, how she wants to be delivered, even until the time of delivery it could be decided. We all know this. So now manufacturers, what they started doing is they produce the product in bulk, and based on the customer's requirement, with the aid of internet, they assemble the product according to this particular customer need, and then they are trying to deliver it. This is fine. With subtractive manufacturing, they were able to pick the mass produced one, assemble it and deliver it. But when it comes to your criteria of designing a product specifically for this customization, for this particular customer, leaving alone mass production, then comes additive manufacturing, where it would play a role in terms of fine tuning the product. And it's another well-known example that we know, all these food products are mass produced. Why I wanted to show is I thought I'll just remind where the closest mass customization to us is happening. I just took an example of pizza and two varieties. Of these two varieties, we can get, according to our order, we can make 864 types. And this is purely based on the customer order. The product has been manufactured, and the manufactured product is been delivered to us by the digitally enabled product customization. So it is very clear customization is already happening, but it is from the mass produced, mass customization is happening. So what we have very clearly seen from the earlier example from the shift in marketplace, that customers started demanding individual products which are highly customized, and the need is having a very high custom product. So this customization is happening at certain places, and in manufacturing, how it can be done or how AM would help in doing this, that comes a requirement. So it is very clear from this, like subtractive manufacturing with the traditional process, it can't be done. It can be only done through a newer alternative, which is the additive manufacturing, where we are looking at one product for one customer, and it stays with that customer, and once the product is done, it goes as a waste. It doesn't come back. So that is where the future is looking at. So it is more of customization which is going on, and let us go through some case studies on this. So before that, I'd like to give a bit of an outline of what our research focus is. So from our research group, we specifically look into two major areas. One is on supply chain, and the other one is on additive manufacturing. So combining these two technologies, we see how we can improve customization, how we can develop complex profile products, high accuracy parts, and a product which requires a reduced lead time. We don't want to wait for a custom product. We don't need to wait for 2 months or 1 month. We are looking for a product to be delivered in a matter of hours, maybe 5 or 6 hours. So that is the lead time that we are looking at. So those sort of products are our focus of research. And as there are numerous number of products, we don't concentrate on entire spectrum. We specifically concentrate in healthcare. And one of the technology that we use is, yes, we have the basic FDM printer by Stratasys. On top of it, we have an Object 260 a Connex machine, and it has an option of 8 print heads, wherein you can have you can print a combination of 154 different material categories, and it's all polymer based. So we don't work on metals, we work only on plastics. So it's a polymer based machine. And one major advantages of this particular machine that we are using at the moment is, as I mentioned, you can go for 154 material combination. We can print a glass-like profile or a polycarbonate one, and we can print a rubber-like part, and we can print an ABS part as well. So these are the three major combinations that we can print using this machine. And when it goes for printing a part, like it takes up two material categories, material A and material B, wherein along with the support material. So material A becomes the primary material and material B becomes the secondary material, wherein you can combine these two primary and secondary material and you can get a digital material, and or otherwise we can also call it as composite material. Um, and using this combination, we can print rubber-like parts, flexible parts. So this gives us an option to print a variety of parts. And within the rubber-like parts that we are speaking, we can even change the show hardness or change the elasticity levels. Like we can print from show hardness 20 to show hardness 100. So where 100 would be a very hard part. So this opens up a very wide option for us to print and use different application. And as I mentioned, we specifically work in healthcare domain, and healthcare domain is again pretty huge. Of that, the broadest classification is on prosthesis, wherein internal and external prosthesis. Internal prosthesis are the parts that goes inside the body, mostly the metal parts, and we don't work anything on the internal body parts. We work only on the external body parts. Speaking of external body parts, like today I thought I'll touch on 5 different case studies. These are all live case studies that we worked on, and I thought I'll speak about these live case studies and how we enable customization on all these 5 case studies. So starting with the first case study, it's on diabetic foot. We all know that diabetes is a fourth leading cause of death, and Tamil Nadu is becoming one of the prime areas within India having a highest diabetic population. And across globe, 20 for every 20 seconds, a limb or a portion of a leg or a leg is lost because of diabetes. And by 2030, it is projected that India is going to be a country with the highest number of diabetic population. And across globe, it seemed to be a growing disease. And by 2040, roughly about 642 million people would be diabetic. So those were the projections. So considering this, we started our research on this particular area. And for this particular research work, we used data from 2,570 respondents, of which 1,885 were male and the rest were the female population. So in this particular survey, we try to analyze what is the history, what sort of diabetic issues they have, and what are the major symptoms that they are facing. From there, we started our work. So when we checked with the respondents, and we could still see most of the respondents were looking at the general practitioners for resolving their issue rather a diabetologist. So that was one area which attracted us, and I'll discuss further on that. And our survey revealed that roughly about 50% of the respondents were aged above 56, and this particular diabetes, the longer the duration is, the higher the complication. So people who were diabetic more than 5 years had 50% of combination of issues. Roughly about 49.5% of the people had issues, and close to 52% of the sample population that we have taken had some issue with their foot. So this made us to narrow down to work something in the area of foot. And looking at the different combinations of issues for the diabetic population, we realized that there were the 5 major problems, and of the 5 major problems, food problem tend to be a common one, and more than 51% of the population were affected with the food issue. So when it came to foot issue, we checked with the patients to know whether they were aware of something called customized insole. And yes, like 43% of the population were aware of it, and 54% were not aware of it, while the rest haven't heard about a term like this. So customization is something that we thought we'll introduce over here in resolving the issue of diabetic issues. So what is it the actual problem is? So speaking of the actual problem, let us say that a patient who is diabetic, he or she tends to develop a diabetic neuropathy. What a diabetic neuropathy is, ideally, this is a normal foot, and when they tend to become diabetic, their foot tends to become so soft. So that is where patients tend to say that their foot became so soft. They started to have a burning sensation. They started to have a tingling sensation in their foot. So this is all a cause of diabetes. Because of this, what happens is our skin becomes, ideally because of diabetes, the skin becomes softer. And as the skin becomes softer, that is the time the skin, when it faces with the hard surface, it starts giving a burning sensation, or it parallelly, for some people, it tends to develop a tingling one. So when it becomes soft, the nerves which are underneath, which are carrying blood, because blood flows from the top to the bottom and it need to go back to the top. So when we are healthy, the blood would flow through our veins like this. Once the foot becomes softer, the nerves get jammed or it starts getting clogged off. So once it gets closed, it stops the blood to flow. So when it stops the blood to flow, the blood which is on the other end of it, so ideally when we walk, the pressure is being created and it starts clogging the blood flow. And once the blood stops flowing, the blood from the top, it comes until this and it goes, it gets stagnated. Once the blood gets stagnated over here, this stagnated blood creates a gangrene, and because of gangrene, it tends to create diabetic ulcers, and these ulcers left untreated, it would go for amputation. So it's all medical terms. Some people would have a question, what does a mechanical engineer has to do with this? So speaking of which, we all know that when we load a
Boss,
particular region with a point load, it there is a major difference in terms of it. What happens is the same one,
কখন আসলে?
if we try to
এখন
use
ঢুকলি?
surface area of contact, now the load distribution would be better
আহ,
as compared to the previous,
তোর
and
বন্ধুটা
it
কোথায়?
makes a bit of a difference.
আচ্ছা, ঘুরে আমি আছি।
So it tends to make a
আমার
bit of
ফোনে
a
না মাঝে মাঝে কিছু শোনা যায় না, জানিস তো?
excuse
হ্যাঁ,
me,
কেন
can
বুঝতে পারছি না।
somebody switch off the mic? So we all know that once if the surface area of contact is increased, the load distribution would be better. So which is very clear from the mechanical perspective. Let's take a person who is weighing 90 kilos, and it is pretty obvious that 45 kilos need to go to his left foot and 45 kilos need to go to his right foot. So that is, we are trying to distribute the load in a proper surface area. And we know that looking at the surface area of foot, our foot is not a flat one, it has some curves in it. And because of these curves, it is very clear the entire load is not distributed throughout the surface. It is distributed in a different manner. Maybe much of the loading happens at a different place of the foot. If the foot load distribution is proper, pretty clear, when we turn our foot insoles, it must be worn off evenly, but that doesn't happen. Our footwear tends to worn at different places in different areas. So this gives a very clear indication to us that the entire loading is not being distributed throughout the foot. So that is something that it need to be done. Loading is different, and surface area of contact is another issue which we need to focus. And looking at the different types of foot, ideally there are three major types of foot. We all of us will fall within one of these three categories. One is the flat foot, other one is the normal arch, and the third category is the high arch, where the high arch are ideally the thin or lean people will be high arched, or the athletic people would be high arched. Normally, people with medium BMIs or a decent BMIs would be on a normal arch, and there are some people who are born with flat foot, and people who are hefty ideally fall under this category of flat foot. So when it comes to footwear selection, we need to be aware of these three terminologies, and based on this only we need to select our foot. But generally that is not happening. That is one issue which we realized. So we have seen that two major issues in our foot. One is the surface area of contact causing irregular wear rate. So these became a mechanical problem. And now, if we look into the activity of us, we have different types of activity. We stand, we run, we jump. We have so many activities to go. So that gives us a clear idea. We undergo static loading and we undergo dynamic loading. So speaking of static loading and dynamic loading, yes, there are some custom insoles which are available, but they don't look into all these parameters. They are just measured according to our shoe size and they have been delivered to us, but they don't really do the job of what it is supposed to be done. So all it happens is you go to your shoe shop, you're not being bothered about what is the type of foot. Are you a flat foot, normal foot, or high arch? It's not been bothered. What is the type of activity that you undergo? That has not been considered. All it has been done is the shoe size is measured and an insole is been given. So this is a mass produced aspect. All we need is another side, which is a customization. That is what we require. And again, within us, there are so many types of foot, and so many of us, though, if you consider two people in this group, they might be of foot size height, but they would be different in weight, they would have different type of physical activity. So all those need to be considered. If we just take two people, we are finding a major difference. Let us go for only one person. If we just take one person from start to end, by his mid-age, he would have his standard foot size, and from here, his foot size would remain standard, but his activities keep changing. So our foot need to keep on changing according to our activity, else it tends to cause issues in terms of ankle and on the knees. That is why as we go older ages, we tend to say that we are facing leg pain or ankle pain. It's all an issue because of not wearing the right custom insole or a custom shoe. So this gives a clear idea that mechanically we need to tackle static and dynamic loading, we need to improve the surface area of contact, we need to reduce friction, and we need to go for customization. So all these four things are pretty much clear when we focus on this. Yes, some people might say that, yes, my grandfather tend to work on fields, he never had an issue, but what is this all new jargons that is coming up? So looking at this, if you go back to that period of time, like he used to be an agriculturist or a farmer, and this is why he walks. Like the foot underneath, it tend to deform according to his profile of the foot. So it was the surface area of contact was high in the early days, or when we walk on deformable surfaces like this, our foot tend to get deformed to the surface and it tend to take 100% loading because the surface area of contact is high. But as we walk on the hard surfaces like what we are walking at the moment, those don't deform and obviously those tend to create an impact to our for plantar surface or to the foot. So this is where we started concentrating. And we very well know that our foot has a curved surface, that is the arch region of our foot. So we never load that arch region, whereas in the previous times, the arch region was loaded and going to the real cycle of it. So arch region is not loaded, and that is one issue we discuss on that. But looking into the gait pattern, the orthopedic perspective of the foot, we all tend to slide towards left or slide towards right while walking. That's the foot walking style that we generated during over the time. So every one of us from the age of 5, we might have developed our own style of walking, and that style of walking stays with us. And when we are designing a custom insole, we need to make sure the gait pattern remains the same. And when we are walking, only 60% of the time our foot is on the ground, or rest 40% of the time our foot is in the swing phase, or it is in the air. So these are some important aspects which we need to consider when we are going for design of the insole. And what we try to do is we try to take the different types of foot, and based on the different types of foot, we tend to analyze the pressure exerted by each and every individual, and we try to, wherever the high pressures are, we try to offload the pressures on the high pressure zones, and wherever the foot is not loaded, we try to unload it. So that is what we are trying to do it. So this is structure how we tend to do it, and what we do is we make a person to walk on a platform. This platform is ideally used by orthopedics after surgery to check the posture, but we use it for a diabetic purpose. What we do is we make a patient to walk on it, and once he or she walks on it, we try to get the pressure distribution. So we make them to walk on it. From there, we try to get the pressure distribution. And based on the pressure distribution or based on its gait pattern, we tend to create a complete custom insole. Like here I have shown two examples. One is the high arch foot and one is a normal arch foot. If you look at this normal arch foot, we divide the foot into 5 regions, 1, 2, 3, 4, and this arch region. So we split into 5 regions, and here this pink region is the very high pressure distribution area. This person, when he or she becomes diabetic, the first place where it would be affected is this particular portion. So all we need to do is we need to offload the pressures here, and here there is no contact at all. The surface area of contact need to be increased, or the pressure distribution is very low over here. Once if we distribute the pressures over here, and once if we increase the surface area of contact, obviously these peak pressures will start falling down. So that's what we are trying to do in terms of this particular research. So understanding the pressure points, we tend to split, as I mentioned, we split the foot insole into 5 different regions, and we change the show hardness. And this is where we completely use additive manufacturing, wherein you can offload the pressures, and in our case we can change the elasticity levels because we are using a photopolymer, and using the polymer we can change the show hardness values, and changing the show hardness values, now we have printed a complete custom insole for that particular patient, for his activity, for his body weight. It is a completely custom made one. If you consider this foot size as 8, this foot size is only suitable for him. Any other patient, it might not be a suitable option. So that is where it's a complete customization. So this is one part which got printed in a Connex 260 machine, and this is the sample part. And looking at the data, you can see that when the same person walked under barefoot, like this is the pressure distribution, while the gray ones are the ones with the custom insole. If you look at it, there is a major difference in terms of surface area of contact. Zone 5, which was not in contact earlier, I've got a contact now, and much of the pressures have been offloaded in various zones. So that gives a clear indication that we have varied the pressure distribution. And we also cross-checked it from the acupuncture perspective. Like if you look at it, our pancreas function tends to take place only when there is a good contact in this arch region. And because the nerve endings of the pancreas lies over here, and since we are not giving any pressure over here in this particular region, so that is where the functionality of pancreas is being reduced, and this is one of the again one of the reasons why people tend to be more diabetic as compared to the early days, because of not the pressure is not being distributed evenly across the surface. And here what I have shown a graph of the distribution of the pressure in the plantar surface of the foot. You could see that the pressure distribution is not erratic as compared to the previous when the person walked on barefoot. Now it is something which is in a steady state, and the pressure distribution are pretty much decent. And the contact surface area had been increased to roughly about 15%, close to 15% as compared to previous case. So this clearly indicates that there is a major change in terms of pressure distribution, contact surface area change, and obviously it will lead to a beneficial aspect when a person wears a custom insole. Like this graph gives a clear indication of before and after. You could see the pressure points have been reduced over here and a better distribution taken place with the highest surface area of contact, which is a pure customization part that we have came across. And this have reduced this particular custom insole have reduced the pressures in various zones, and in total it have reduced close to 30%, or on average it have reduced the pressure distribution by 30%. And we have applied for 2 Indian patents and 2 UK, I mean the international patents. So, and we do have some publications on this particular research work. So, concluding from this particular research, we have completely made a change in static and dynamic loading, improve the area of contact, reduce the friction, and improve customization specifically for that particular patient. In conclusion of this research that we analyzed is not only for a diabetic patient, every one of us at a point of time we need to go for custom insole considering our activity. Else, because we have heard people saying that we need to take care of our food as good as we take care of our face, so which is very true in this case, and we need to be aware of it. So the next thing that I would like to touch is on dental aligners, how we involved pure customization for dental aligners and how we change the scenario in terms of undergoing the dental alignment. That is, we have seen these situations wherein if you want to bring the tooth from this state to this state, dental aligners is one essential thing. And when it comes to aligners, this is the currently used technology wherein we use braces. So braces are used, but we can understand the pain, or people who went through these braces, they would know the pain of putting a brace, and it is hard to uh, take food, or cleaning becomes an issue, and it is a very tedious process. And this technology was adopted before 200 years, or way before that, or and from there only the type of uh, application is changed, but still the braces remain the same. So this is a very old idea that the dentists are still following or still be adopting. Yes, there is a new alternative which was introduced. Those are called clear tooth aligners, wherein it's again a polymer-based material. What they try to take a mold, and from the mold they tend to make these dental aligners. Now the idea is even if you wear it overnight, you can still arrive at your dental correction. So that is where this new technology has been adopted. But is this still the new technology a very good one? So that is why we thought we'll do an analysis. And in order to get adopt or stick to this particular technology, the lead time is quite high. It takes at least 1 week for a dentist to fine tune this, and then comes the application. You still need to have continuous customer visits or patient visits visiting a dentist, and from there they tend to keep taking the positive and negative mode, and then they tend to keep doing the corrections. Because usually what they do is they take one tooth as a reference, and let's say if they are taking this tooth as a reference, they would align these tooths first, and then once after aligning the left portion, then they will take the left portion of the tooth as a reference, and then the alignment of right tooth, right side would take place. So this is why we thought we'll work on this research area. So looking at the current technology, how it is being done, it all goes with taking a negative mold. Like we visit a dentist, the dentist gives a negative mold, and he asks us to sit holding the negative mold or biting the negative mold for another 20 minutes. And we need to sit in that standstill position for 20 minutes. One important thing is our body is designed in such a way we can't sit still for more than 30 seconds, because our body will slightly make a move. Very clear from this, once if we start moving slightly, in a matter of 20 minutes, we might have created a clearance gap of more than what is required. So now itself, whatever the data that we have given to the dentist, we are not giving a right data. Okay? And another parameter is we can't measure any dental activity. Let us say that we need to tilt a tooth by 2 degrees. There is no measuring device that is available to keep on the face as a reference and measure or make a tilt of 2 degrees of one of our tooth. We can't do it. It's all been done through a complete approximation. So this is where we thought, okay, though we have so many technologies from the mechanical perspective, still this field, which is one of the very essential thing for every human being, it's still there is a missing factor over here. No accuracy is being done, and we have such a discomfort, and we face this discomfort day in and day out, and this is one of the hardest part to take in. So that is why we thought we'll explore that. Moving to the current method, after taking the negative mold, they tend to make a plaster of Paris positive mold. For the positive mold, they tend to take a vacuum molding. After taking a vacuum molding, they tend to cut over the edges using a scissor, and this aligner is ready. And this is what is given to the patients to wear for 15 days, and then they keep iterating this process again and again. Usually, this process goes on for another 10 to 12 sittings until the tooth gets completely corrected. So you can imagine the time that you have been wasting and the amount of stress that a patient undergoes with reduced accuracy ranges. So what we did in this particular scenario is we used one of the dental scanners. We took the complete scanning image, and we, after taking the scanned image, we moved this entire thing because we can't work in working in CAD-based systems is difficult. So we moved to Hapticom. Hapticom, that's one area wherein we can work flexibly like a clay molding sort of thing. So moving to Hapticom, now we can measure it very accurately. And let us say that I want to keep this tooth as a reference and I want to modify this. Let's say now I can easily measure what is the angle of this particular tooth and how much degree I can tilt. For one correction, the maximum we can do in terms of tilt is 2 degrees is the maximum tilt that we can do for a dental tooth. So we started doing it for an accurate range, and doing it at a very accurate range, we slightly tilted it. Once after tilting it, we fine-tuned the entire dental process, the correction, and all we need to do is we need to give a layer thickness for this particular the existing scan data, wherein we gave a layer thickness of 0.625 mm, and this aligner became one of the Asian raw data for 3D printing, and for which we printed using the Connex machine, and this application was given to the patient. So now we could see that we are dealing with a highest level of accuracy. Now the patient doesn't need to come back for every correction because we have this dental data with us. So the next set, we know that we have from the earlier stage, now we have tilted it to 2 degrees. Now all we need is another tilt along with the correction on the other portions. It could be done without the interference of the patient. The entire data has been collected and it has been dealt with. On top of it, now we are giving a high customized aligner which shoots only for that particular patient, and this is with a very reduced lead time. Once if the patient says that his time of 15 days is over, next day evening he can come and collect it, or once he is ready, this could be delivered in a matter of 4 hours, because 2 hours is the printing time, half an hour is the post processing time, and the dental aligner is ready in a matter of 4 hours. Wherein earlier it was a lead time of 7 days with much of a discomfort. Now we are dealing with the highest accuracy with reduced lead time, and the product has been delivered to the patient. So this is the 3D printed one with the support structures, polyjet printed one, and this is the complete dental part which is given to the patient, which is a complete mold-based one. And we did happen to have a publication on this recently. Next case study, moving to orthotics. We all have seen children with club foot. This type of foot ideally is called as club foot, and this club foot need to be treated on patients by the time they are born. You need to start the treatment between 4 to 6 weeks by the time they are born. If not, it becomes very hard to treat the club foot because during early days, bones are very fragile and quite elastic, and it is very easy to do it. The current method in which it is being done is it's by plaster of Paris method, wherein the baby is made to undergo a plaster of Paris mold, and a mold is being or poured on that child, and once it has been poured, uh, it is left in that same state for another mm, 15 days, and then again the baby is brought back, and then they would rip off the mold, and then they will pour another mold. That is for every time, more like the previous dental case. Here the maximum correction they can do is 5 degrees, and that is the maximum correction that they can do. And again, there is no measure to say that they have changed it to 5 degrees, because you can't measure the existing human bone for a deviation of 5 degrees, and it's all been done for an eye approximation. One more thing with this particular plaster of Paris mold is, let us say that a born baby is roughly about 3 kilos, and this treatment need to be started within 4 weeks from the time the baby was born. And what we are saying is we are adding at least 900 grams of this plaster of Paris mold to the baby, who only weighs about 3 or 3.5 kilos. So we are speaking of a weight of 30% of weight adding to the baby, a newborn. On top of it, when this plaster of Paris cures, it tends to liberate a certain amount of heat, close to about 40 degrees heat is being liberated. We can imagine the pain that the child undergoes when a plaster of Paris mold has been poured, and when it gets cured, a temperature of 40 degrees of heat is being liberated to the skin. It's quite a tedious process. And that too, maybe sleeping with this particular plaster of Paris mold during early days because of biological reaction, cleaning becomes a tougher process, and whatever the mother tries to clean, still children tend to get some sort of infections because of this traditional technique. And yes, there are some post correction options wherein you have options like Michelin shoes, Dobbs bar, Iowa brace, all these being used as a post correction method. But one thing essential with this is you need to have both the legs in order to do this correction, because again here one leg has been taken as a reference for other leg, and then the correction has been done. We can imagine a situation wherein you tie both the legs, because for a newborn, that is the only movement that they have, moving their hands and legs. Now we have arrested both the movements, I mean both the legs movement, and it's a very tedious process, and our technology is not supportive for this particular scenario. So that is one area what we thought we'll explore. So this is a sketch of it, wherein a baby is taken, a plaster of Paris mold has been poured, and after a correction is done here, not 100% correction is done, roughly about 70% correction is done, and rest it goes with Michelin bars and Dobbs bar, wherein you need both the limbs in order to do the correction. And it's quite a tedious job, because sometimes the fitting is improper, size changes, because during early days the size of a baby keeps on changing, and every time and then you need to keep changing it, and the weight of a brace is one issue. So there are so many complications that are involved when it comes to this bracing. And again, there are issues like sores that have been developed, skin ulcerations that have been developed, weight of the cast, and time that it takes in order for this correction. So there is a huge amount of complication that is involved in terms of this. And there are again some crude methods, where like the spin methods, which is being used in order to do the correction, and still some children are left with the situation. Even after such a pain, they are not being corrected, it would still remain the same. So for this particular issue, we thought of exploring how RP could be done, because again, this is a specific customization requirement for that particular baby, because the size changes every 15 days, the size of the limb changes, and we need to give a highest accurate part, and we need to go for a solution wherein we can reduce the existing issues like sores and improving the accuracy. And for this particular scenario, we had a child wherein his issue is he's not been treated, because the problem is he doesn't have another limb, because the market available one, you need both the limbs to treat them, and there is no another limb for him, so that left him untreated. And again, treating him became an issue. So for that reason, he was not being treated. So then we took this particular scenario and we started working on research. And what we did is we came out with a mechanism, completely a 3D printed one. We scanned his foot, and for his foot size, we came out with a ideal mechanism wherein it gives 6 degrees of motion, dorsiflexion, flexion, that is up and down movement of this leg, the sideways movement of this leg, and the tilt of the foot, a slight tilt. Usually, every one of our foot can tilt for 30 degrees. So this 30 degree slant is also being corrected. So that is where our focus was. And using this mechanism, we can, dorsiflexion is done through this, plantar flexion is done through this, and mm, abduction and adduction was done through this. So all those 6 degrees of freedom was brought in, and we tried to do a correction for this particular patient. And this is the 3D printed part, which is completely customized for that particular patient, and it could be used for 1 month, and then they would go for another correction. And very importantly, it is not like a plaster of Paris mold. All it does is it is being connected to the limb or as an external body part, and the orthoticians or orthopedics suggest that if a kid wears it for more than 9 hours or for close to 9 hours per day, that is more than enough. So now this gives a flexibility that a kid can wear this for 9 hours, and after 9 hours, even the mother could remove it and she can put it on the next day. And when it comes to calculating the degrees, now we are speaking of the entire mechanism is divided for every 0.5 degrees. So it's all like you can just remove off these gears, tilt it for a 0.5 degrees and insert it back, and yes, you get your accurate tilt of your limb. So this is one part that we produced, which is for custom orthosis. And we had a publication on this, and this is there in Rapid Prototyping Journal. You could find this paper on this. And yet another case study that I would like to touch is on trachea, trachea or the foot pipe. As we are closely working with some hospitals and doctors around here in this region, and we had one issue with a hospital, and they had a patient wherein the patient need to be treated by a surgeon who does surgery on trachea, and they also need another surgeon who is a general surgeon to be around for this particular operation. And there were two different people, two different surgeons who are involved in this operation. And for this particular patient, the problem is there are two doctors, two surgeons who are involved in this operation, and one surgeon can only see he uses a bronchoscopy to look at the images. That is, he looks at 3D images. Whereas the other surgeon, he looks at images in 2D form, or an MRI or a CT image. He uses an MRI scan data. So he is well versed in looking at 2D images, and the other person is well versed in looking at 3D images. But these are two different surgeons, and though they say that they are very much clear in those images, still one of their head surgeon was not very sure whether they are very clear in understanding those images. So that became a criteria that they wanted to see um, the entire trachea before undergoing this complicated surgery. And very importantly, when they wanted to have two surgeons involved in this, all they need is they can't open or pierce open the body, look at the trachea and make some decisions, and then they can't go back to the surgery because the surgery itself is a complicated one. So that is why they came to us for a possible solution. So what we did in our perspective is we took the scan data of the entire trachea, which is a DICOM 5. We and they wanted to undergo a surgery in one of the regions, the bronchi tree, and that is the region where they wanted to undergo a surgery. So we took that particular portion, we split the entire trachea into various modules. The reason is because the top portion of the trachea is quite hard, and as it goes further down, it becomes more flexible. So this is why we kept on changing the show hardness values from 80 to 20. It is just to give a more or less a feel of the existing trachea. And we completely 3D printed the entire part using a digital material. And once this part has been printed, the printed part with the support structures and the part with the support structures, which is a post-processed part, wherein we have removed off all the support structures. And I mentioned to you, like we split this entire part into different zones with varying show hardness levels, or more or less to reflect the existing trachea. Though we can't measure it, just by approximation, we try to print it. And once after printing it, now the entire part is given to the doctors, and the surgeons try to, now they have a better visualization of the trachea, and they practiced surgery beforehand, rather case opening the body and taking the time to decide on. And since we gave a complete model of it, which is an exact replica of the existing system or existing trachea, both the doctors were convinced with the data, and now they had a better idea. And this also, in a way, this reduce the healing time of the patient, because as like the earlier, now they know exactly where they need to pierce open the body. Let us say that rather starting to pierce open from this region to this region, now they exactly know that this is the region that they need to pierce open. And they got a clear idea of, because they practiced the surgery before doing the surgery itself. So now they were able to pierce open only that particular section of the portion, and they finished off with that, and the patient was quite relieved in terms of the pain, and they were able to do it. And the produced trachea, it exactly replicated the actual bronchoscopy image. So they even tested it trying using a bronchoscopy. So this is one region where we used 3D printing completely for customization. And one final thing that I would like to touch is on bed ulcers. We all know that bed ulcer is one of the major issue, and it is otherwise called as decubitus ulcer. And this tends to occur to patients who are in bed for quite a long time. Either patients go to bed because of any complex surgeries, or people who are in coma, they tend to go home in bed for a longer time. The situation with decubitus ulcer is, ideally, when a patient falls coma, for first 3 days, the patient has been treated for the disease what he or she came in. And after a week, they'll start with the treatment for treating this decubitus ulcer or bed ulcers. So the first 5% of the treatment starts with treating the patient for the ulcer, and 95% goes for treating the actual issue. As the patient reaches roughly for a timeline of 3 months, it comes to a situation of 60% of the treatment is for the issue what he or she came, and 40% of the treatment is done for or treating the ulcer. And the moment the patient crosses uh, 6 months in bed, Now 80% of the treatment is done for the ulcer and only 20% is done for the actual issue what he or she have came in. So this is one of the major issue which is slowly popping up. And in India, roughly there is about 5% of population who are undergoing this issue, and this is one of the most neglected issue in terms of medical perspective. And there are a couple of deaths which are happening because of this particular issue. And since we had some previous experience in terms of treating uh, wound ulcers, which we saw in our diabetic foot insole, wherein we dealt with static and dynamic loading. Now there is no dynamic loading. Only thing that we need to do is we need to undergo a static loading. And how can we improve the surface area of contact so that we can distribute the pressure? And since we had that experience, we explored into this particular domain as well. So looking at, again, this becomes one of the mechanical problem, wherein the force of pressure, the shearing force of the skin, the friction between the skin and the cloth or the skin and the bed, and obviously because of the reason of lying there for higher duration, the moisture and poor mobility, and then comes some of the medical factors. So the primary five issues are straight away the mechanical issues, which we thought is essential to resolve this, to overcome this bed ulcer issue. So that is where we started exploring further. And how it happens is, when we are in bed, we exert a pressure, and then occurs a shear. Shear occurs between because of rubbing between the bone and the subcutaneous fat or the skin inside. There occurs a shear, and there is a friction force which is happening between the skin and between the cloth or between the bed, and the friction force happens on these regions while the maximum shear happens in the hip region. So these are some of the areas where it ideally starts, and this gives a better image of the weight distribution, the pressure force, and the shear force that happens between the bone and the internal skin, and the friction force which happens with the outer layer of the skin and the cloth which is outside. And this is one major issue which tends to occur for people who are there on wheelchairs. It tends to happen, and for people who are on bed also the same issue tends to happen. So it is a very clear issue in terms of friction and shear, and we, from our experience, we realized once we distribute the pressure evenly, obviously we could overcome this. All we need is some mechanism in order to custom distribute this pressure forces, because the body profiles are different and the issues on each and every body profile is different. So it demands a very high customized bed for one patient. So that is what our focus was, and that's why we thought of using 3D printing to overcome this or resolve this issue. So usually these are the 4 stages how it occurs. Stage 1, wherein we sit in one particular place for more than 30 minutes. It's called as epidermis intact. So we need to move a bit, else initially it all starts with a sort of heat generation, and that is where the stage 1 is. And stage 2 is once we sit in for a prolonged period of time without even movement, and that is why it starts making the skin to be tender, and that is where it starts creating the first stage. In easier phase we can say it as creating the skin rashes because of the frictional activity. Then the third stage comes in, wherein it tends to disturb the more the rashes are, and still the particular rash which gets untreated, the subcutaneous, it goes until to the subcutaneous fat, and then starts the major issue in terms of bed ulcers. So we tend to deal in these two regions, wherein how to treat the subcutaneous fat issue, subcutaneous tissue issue, and how to deal with the decubitus ulcer issue. So this generally tends to occur for people who are a bit mobile and who tend to sit on wheelchairs. For them, this issue tends to be predominant, and the fourth stage, it occurs for people who are completely bedridden. So these are some of the primary areas where the highest pressure points tend to take place. The ischium or the hip joint, 28% tends to occur. The sacrum or the buttocks portion, wherein the second distribution or the second highest area, and then comes the joint regions where we have the heel points or the shoulder bone points. So these are some of the regions where we need to concentrate and what we try to do. And the limitations with this is it's a very time consuming process, and they don't have a clear idea of pain management. And pain management, they are generally treated with painkillers or other support structures have been done at the moment, but still they are not so convincing, and that would demand more amount of medicines which are going in and which further causes some side effects. Yes, there are some market available products. One of the cheapest option is a foam bed. The other option is an air bed, and the third option is a water bed. The problem with this water bed is, yes, with air bed and foam bed, it's all an artificial leather made process. The moisture content becomes very high. Water, even if you try to put a cloth on it, yes, the moisture becomes an issue. And once there is a bed ulcer which starts up, it can't be stopped because of the moisture. It keeps on going worse. And one issue with the air bed is it keeps on pumping air for every 10 to 12 minutes, they need to pump on air to make a slight movement. So imagine a situation wherein you're lying in a bed for a prolonged time and you hear an hissing sound for every 12 minutes because of the air flowing in. And this being very flexible, you feel you more uncomfortable as compared to a normal bed. Though it tries to offload the pressures, that doesn't solve the purpose. Then moving to the liquid bed, these are very costlier process, and these beds goes to a cost until 2 or 2.5 lakhs in cost, and they need to keep replacing the liquids every 12 days, else it will start spoiling the entire bed. So that's also, again, the moisture is an issue, and even a slight change would start damaging the bed. So these two, although they are very expensive process, it can't be used. And another thing with this particular one is, once if the patient is being treated, they need to dispose of these beds because they can't sterilize these beds. So that becomes an issue. And with the traditional foam beds, no, it doesn't do a job as like this, but those are cheaper ones, and those need to be disposed. And again, it would ideally delay the bed ulcers, but it would still tend to give the bed ulcers. So until now, there is no real solution, much of a cheaper solution or a better solution for a customer while it comes for treating the bed ulcers. So this is where we focused on our work, and we came out with a solution wherein we completely designed a custom bed for an individual patient based on the pressure points, based on the surface area. We completely redistributed it, and in our design, we gave a better option for air circulation, so that there is no moisture which gets accommodated in the bed. So once if the moisture content is reduced, automatically the healing of the wound will start taking place. So the moisture content was reduced, air circulation was improved, and the bed is 100% completely customized one, which changes the bed entirely, changes its profile according to that particular patient. So that is what the bed that we designed, and the bed that we came out with is, we can reuse the bed for another 5 times, wherein you can completely sterilize the bed and you can reuse it. It tends to give a better circulation, blood circulation as well. And sorry, I can't go much detail into it because we applied for 2 patents on that, and we just got uh, one patent, and yet another one is still pending. So, but I could just give you an idea of what we did in terms of customizing in terms of bed. So, having discussed over the case studies, So customization, my conclusion would be customization is already happening, or a pure customization specifically concentrated for individual patient for a product which can be only used for him is already happening. And I showed you through a couple of case studies like the foot insole, orthotics, dental, internal body organs, and customized bed. So it's all happening where there is a demand, and it would be soon, it would be in other parts of manufacturing. And it is possible, what I have seen, this is from my personal perspective, it is possible only through additive manufacturing you can enable much of a customization as compared to any other technologies. Okay. So I would like to acknowledge my couple of my scholars who worked with me on these particular areas. And just to give another note, yesterday you might have had Dr. Srikanth, who gave an idea on laparoscopic tool. Again, that was an outcome of one of our work, um, wherein Dr. Srikanth was my scholar, PhD scholar, and we came out with a novel laparoscopic hand tool, a surgical tool. So, yeah. Thank you. Thanks for your patience, and I'm pretty much open for discussion. Any questions, please? Um, Thank you, sir. I'm pretty much open for questions. Any questions, please?
Hello, am I audible, sir?
Yes, ma'am. You're pretty much audible.
Yes. So I have a question regarding dental surgical guides. So you
Right.
have worked in the domain in the dental aligners. So can you
Yes.
tell how the dental surgical guides work and how 3D printing is, innovating that field as well?
Um, Perfect. I do have some idea on surgical guides, but I don't work on the surgical guides. The thing is, surgical guides, it all it requires is you need to work on internal prostheses. Internal prostheses, those go with the metal parts. And again, there are some issue in terms of using metal parts inside the human body, about 9 months before. We all know that titanium is one of the, if you compare titanium and a bone material, obviously titanium is a very hard material as compared to our bone. But there were patients who had been implanted with titanium metal parts before 14 years. And about a year before, there was a publication by Royal Society of Medicine stating that they could find the titanium metal parts in the bloodstream of the human body. So that means that we are not very clear in terms of using metals inside our human body, and that is a big domain which has so much of discrepancies of its own in terms of that. So, and we need to go for so many medical approvals while putting anything inside human body. So for that reason, I don't work on. And again, in terms of using these dental surgical guides, ideally what they tend to do is they take the mandible portion, like more or less the scanning technique what we use, like they take an MRI or a CT scan of a jaw. For that particular jaw, they tend to make the mandible. Still, they would use magics like hapticom and geomagics in order to um, make the surgical guide. And once they are done with that, they go for 3D printing, and sometimes they go for a heat treated post processing process before putting the surgical guides in. And that's a separate domain. And if you could send me your an email, I can share you some
Absolutely.
materials on that. that I can do from my perspective, but I can just give you an outline. Yeah, yes, those are internal processes, metal parts. I don't work much on those internal metal parts.
All right. Thank you so much, sir.
Thank you, ma'am.
Good morning, sir.
Yes, please. Good morning.
My question is regarding you have created the 3D printing part for internal body organs. So
Yes.
how you have collected the data for that?
Okay. Ideally, we got a scan data through MRI scan, and getting the MRI scan, we got the DICOM file, and DICOM file we converted. We used Magix to work on DICOM file because we converted the DICOM to D2P. We have a D2P software for our use, and DICOM file we converted into D2P. Used a D2P software. We worked on it, and from there we take it for print and we printed it.
Okay, sir. Thank you.
Thank you. Any other questions?
So, which material is used for a general prototyping purposes in medical field?
Okay.
Are they resins or are they PLA materials?
Here, in our case, we used ABS. Most of our applications, we used ABS as an material, and some cases we used photopolymers, like ideally the acrylic-based ones. Like the dental one, we used acrylic ones, and for orthotics, we used ABS. For custom insole, we used Tango Plus, a material which is specifically for Conex. Um, Tango Plus, and we used Tango Plus is ideally a flexible rubber-like material, and we used Veroclear, wherein it's a combination of. If you look at the sole, you could see it's a combination of both um, Tango Plus, this one. This is the insole that we printed. It's a digital material that we used, a Tango Plus and a Veroclear, where Veroclear, a plain Veroclear is nothing but it's more like an acrylic sheet or a polycarbonate sheet, which is quite very transparent. But a combination of Veroclear and Tango Plus gives a flexible one, wherein Tango Plus is like a rubber-like material. And in terms of when we went for aligners, we used Veroclear, the same Veroclear that we use for foot material we used over here, but it doesn't have a Tango Plus. So it doesn't have rubber-like material, it's only a Veroclear, more or less like a polycarbonate sheet. And in terms of orthotics, we used a complete ABS, which we printed in an FDM printer. And for this, again, we used a combination of ABS, wherein we call it as Vero White, um, which is ABS, and Tango Plus, which is a rubber-like material. So ABS and a rubber-like material combination was used over here for this particular application.
Thank you so much, sir.
Thank you.
Hello.
Yes,
Good
please.
afternoon, sir.
Yes, sir. Very good afternoon.
Which food shape is better for human being?
Sir, your
For example,
audible,
sir, if
your
you have-
audio is not clear.
Sir, I am asking which food shape is better for human being?
Which foot is better
Mean-
for?
Food shape, sir. Or better for
Okay.
human being, sir. If
Okay.
one candidate have normal foot shape, he will follow some diseases, or someone have arch shape foot, he will not affected by any disease. I want to ask
Okay.
like this.
Right. Okay. There is no right or wrong foot shape, to be honest. But only thing that we need to be aware is we need to understand what our foot type is. Like, let us say that you're a person with normal foot. When you go for selecting your foot size,
Yeah,
all you need to do is you could see some people wearing a very high heel shoe, and you would see some people wearing a very flat bottom shoes, or and there are some shoes which are available in the market with a medium heel. So what we need to do primarily is a medium heel can be worn only by a person who has a normal arch. A no heel shoe or no heel sandal can be worn only by a person who has a flat foot. And the people with a high arch, they are fine to wear a high heel shoe. But usually, what we do is we don't look into this. We only look at the aesthetics of the shoe and we tend to wear it. And the worst of all of everything is the pointed shoes. We should never wear the pointed shoe. So, to start with, one thing is never wear a pointed shoe, because in terms of pointed shoe, it alters your gait pattern entirely. That is number one. Because your when it comes to the last stroke in the gait cycle, our front toe need to take the load, but front toe need to take the load, and the last finger in our foot need to the last toe in our foot need to take the load. But when we wear a pointed shoe, that disturbs the entire pattern of gait cycle. It doesn't leave the um, entire sole to take the load. That is one thing. And second important thing is, based on our foot type, we need to select our shoes. The best, if you are a normal foot, select a shoe or your slipper which has a normal heel in it. And if you are a person with high arch, go for high heel. If not, don't mismatch it, because that is very crucial. If we mismatch it, we that is why we tend to get ankle and foot pains at a later stage of our time. Uh, did I answer your question, sir?
yeah. Thank you, sir. Sir, it also affects blood circulation. It also
In terms
blood
of,
circulation in
yeah,
human beings.
yeah.
Human
In terms of blood circulation, until now, ideally what we need to do is we need to increase the surface contact area of our foot. That is, we need to go for an arch design. We need to load our entire foot. But at the moment, most 99% of our
Thank you, sir.
footwear doesn't have that option.
Hello, good morning, sir.
Yes, sir. Very good one.
Yes, sir, I have a,
Thank
I
you very
have a
much.
question.
Yes, please.
Sir, in which software we can create the program for the 3D printer?
No, sir. In our situation, we don't do any programs. What we do is we either use the scan data, and using the scan data, we tend to fine tune according to the body profile.
Oh, means through scanning we can automatically get the program for this model or
Yes, yes.
okay.
Like if you look into the dental one, it's all the scan based data that we work. Like it's a complete scan data that we took, and we use this scan data as our base data, and we work from here.
Okay. Okay. Thank you, sir.
Thank you.
So one question from my side.
Please.
So I want to ask how we will model the pressure points of the foot.
Right. For that, in orthotics, there is a device called as EMED platform. I can quickly show you that. Like this is an EMED platform. When we stand over this platform, ideally it has pressure sensors. There is a pressure sensor for every 1 centimeter by 1 centimeter size, there is a pressure sensor, and that pressure sensor tends to model our foot pressure loadings. And this is already used by orthopedicians, and they make the patient to walk on this once after completing the hip bone surgeries or hip surgeries. After completing the hip surgery, they use this in order to understand the gait pattern. So we used the same technology for our requirement, and this line which is going in, it's called as a gate pattern. So we use the same technology to capture the pressure distribution data. It's an EMED platform. You do a Google search in web, you'll search for EMED. It's a German-made equipment. It's called as Novel DE's EMED.
Thank you, sir. Thank you very much.
Thank you, sir.
Really wonderful session, sir.
Thank you, sir. Thank you, sir.
Very, very great, sir.
Thank you, sir.
Participant, if you have any doubts, if you have any doubts in this regard, today's session.
Hello.
Yes, sir.
Good morning, sir.
Yes, please. Very good morning.
Hello.
Yes, please.
Good morning, sir.
Good morning.
I have one question. So, if we are organizing this type of event, so are you ready to join this? Join our FDP?
Yeah, I'm pretty much fine to do that.
Okay, sir. Can you share your number?
Sure, sir. I'll
just cell number, sir.
Yeah, sure, sir. I'll just I just typed in the text box.
Okay, sir. I am from Pimpri Chinchwad College of Engineering, Pune. Working as an assistant professor. So I am interested in this topic, 3D printing, and I think your topic is better. I feel better for PhD also.
Sure. Okay.
Okay, sir. So if you are interested, if you are ready, so I'll contact you for the same.
Sure, sir. No problem. I have given my phone number and my email ID. You can contact me. Or even my details are available with Professor Mani as well.
Okay, sir.
Okay, sir. Thank you.
Thank you.
Is there any other questions? Dear participant, next session start on 12 noon today. If you have any questions for this session. Okay, sir. So today the first session, seventh session, having third day, the first session is very wonderful one. Dr. Rajesh Ranganathan, sir, handle for this session. Very wonderful, sir. Thank you, sir.
Thank you, sir.
The current and existing for the industrial requirements, based on the industrial requirements, is actually what is going on for this 3D printing and other things. About very clearly handle it, sir, for this session. Thank you, sir.
Thank you, sir. It's my pleasure. Pleasure to be here. And thank you one and all for your patience. Thank you.
Dear participant, anything? Sir, presentation will be closed. The photo session start. Dear participant, unmute the video. To start the photo session. Sir, presentation will be closed. Doctor, sir. Presentation will be closed. PPT.
Sure.
Your photo, sir.
Okay, thank you, sir.
Hello, sir. Sir.
Thank you, sir.
Hello, sir.
Yes, sir.
Sir, photo. Thank you, sir.
Thank you, sir. Pleasure, sir.
Thank you, sir. So much.